This is a short video clip about the reaction of vanadium. We're going to start by thinking about the different ions to be aware of. So we have the +5 oxidation state, +4 oxidation state, +3 and +2. The colours are listed here, so yellow, blue, green and violet. So the reason this is in the specification is really to think about the variable oxidation states of transition metals, and also to think that when they change the oxidation state they change in colour, which is typical of the transition metals. So first of all, let's think about the reactions with zinc. And reactions with zinc leads to this change from the 5+ oxidation state to the +2. But you need to really be aware of the different changes that take place through the different oxidation states as the reaction proceeds. So in excess, the zinc will go all the way over to the +5 to the +2 oxidation state, so that reaction will take place. But what we're going to think about here is the individual step by step. So we have first of all the VO2+, which is +5 oxidation state, changing to VO2+, to yellow, from yellow to blue, so the +5 to the +4. And this reaction is carried out in acidic conditions because the oxygen needs to be released and to form water. So the H+ ions here will react with the oxygen of VO2+, forming water, and the acid provides the H+ ions. So hydrochloric acid, HCl, release protons to allow this reaction to take place. The other part of this half equation is the electron, which comes from the zinc, and it's one electron required because this is +5, this is +4, so you add one electron to make that change. Also, another way of looking at it is the charges. So there's a +3 charge there, +2 charge there, so add one electron and now the charges are balanced. So with the zinc, it's a reduction of zinc from zinc to zinc 2+, oxidation of zinc to zinc 2+, loss of electrons, which is always the case with zinc. It has two oxidation states. And then combining these two equations together, we need to make sure the electrons transferred are equal, so gained from the VO2+, released by the zinc. So we double this equation here, and so that leads to this overall ionic equation once you combine the two together. So the next reaction is the reaction with the VO2+. Now the superscript 2+ of +4 oxidation state gets reduced to V3+. Is a blue to green change. And it's very similar to the one above, in that the VO2+ gets reduced to the V3+, releasing one oxygen to make water. So to make water you need to have the acidic conditions, so it's 2H+, and add electron because it's going from a +4 oxidation state to a +3 oxidation state. At the same time, the zinc does exactly the same half equation as above, zinc to zinc 2+, and then combining these two equations together, you again need to multiply this by 2, and then what happens then is this becomes 2 electrons with everything here multiplied by 2. So combine the two together and you end up with the overall ionic equation written here. The final step is that the V3+ is reduced to V2+, that's green to violet. This is the final change. It doesn't get reduced any further than that to, say, vanadium metal. So the V3+ electron goes to V2+. The zinc gets oxidized to zinc 2+ and releasing 2 electrons. Times this equation by 2 when the electrons are going to get transferred from the zinc to the vanadium 3, and then you get this overall equation. So we'll then just want to think about one other important part of the acid in this bottom bit here, this bottom section. So it says that we've also got a second reaction. This is a lot of fizzing going on. There's a lot of hydrogen being produced because the zinc is also react with the excess HCl. Loads of HCl in this test tube, because we need to go through all these steps providing all these H+ in all these reactions here. So, but another reason we add lots of HCl is because we need to make H2. H2 drives out oxygen from the test tube, and the purpose of that is to push out any oxygen that may be in the tube, which may well oxidize vanadium back to, for example, 3+. So the V2+, if you allow oxygen to be mixed in, it will be oxidized very easy back to the 3+. So that's another side reaction that's taking place, which allows us to see the violet of the 2 plus. Now, I've shown individual reactions here, but what you might be asked to do is to write the overall equation for the full reaction. So if we take VO2 plus 5 oxidation state to the 2 plus, this is the half equation balancing with waters, then H pluses, then the 3 electrons to go from +5 to +2. The zinc changes to zinc 2 plus, so we're losing 2 electrons. And then combining these two half equations together, times this by 3, times this by 2, and you will get the overall ionic equation written there. So it may well be that you're asked to write the overall ionic equation for the whole reaction, and you can see that zinc is clearly in excess, 3 to 2 ratio there, it's in excess to allow that reaction to happen.